Welcome to Cyber Talks, where we discuss all things cyber in short. We'll share real stories, practical insights, and exciting tips based on our experiences and expertise. Let's start. My name is Gil, and I'm a research director at SCI. Today, we will talk about common development mistakes in your application security.
We've been hearing about SQL injection and cross-site scripting vulnerabilities for ages. Are these vulnerabilities still relevant in 2022?
Yes, SQL injection and cross-site scripting vulnerabilities are still very relevant. Although advanced frameworks greatly reduce the risk, many applications that use older technology stacks are still vulnerable. Modern technology stacks can also be vulnerable if the code is written with bad coding practices.
How common are these vulnerabilities?
OWASP Top 10, which rates the hottest topics in application security, have been rating injections and SQL injection at the top for many years. However, we see less SQL injection and cross-site scripting than we used to in the past. So it is no surprise that in the OWASP Top 10 2021 edition, injections are down to third place. But the bottom line is that we still see it in 2022. We've been scanning multiple web applications using automated tools and found many of them were vulnerable to cross-site scripting. You can see some examples in the following slide.
What can I do to be safe?
In order to create safer systems, first and foremost, use modern technology stacks. If you're creating a new system or an old system can be refactored, choose modern frameworks. To reduce the risk of cross-site scripting attacks, for example, choose advanced JavaScript front-end frameworks such as React, Angular, or Vue.js. To reduce the risk of SQL injection, when you access your database, use modern data access layer frameworks, also known as ORM, or Object Relational Mapping. These frameworks allow accessing your database without writing raw SQL code, which is one of the main reasons for SQL injection. Note that it's preferable to choose an ORM that does not use strings, such as .NET Link, Python SQL Alchemy, or Node.js Sequelize, to prevent a similar attack called ORM injection.
If I follow these best practices and choose modern technologies, am I safe?
No, choosing modern frameworks is not enough. Advanced frameworks help mitigate injection attacks, but there are still business logic and access control violation vulnerabilities. Transferring a negative amount of money in a bank application is an example of a business logic vulnerability. Furthermore, the most common vulnerability nowadays is access control violation. In this vulnerability, a low privileged user can access a high privileged user's actions or data, or can access another low privileged user's data. For example, a bank's customer that accesses another customer's information. Access control violation is OWASP Top 10 new number 1.
Is access control violation a new thing? Can advanced frameworks help with it?
Access control violation is not new, but now that injections are less common, it takes the focus. Advanced frameworks and libraries can help reduce the risk of access control violation, but it does not guarantee that no vulnerability will be present. Advanced frameworks that prevent SQL injection can be vulnerable only if the developer forcefully writes bad code to bypass the framework's defenses. Access control frameworks, on the other hand, gives you the tools to write secure code, but if you forget to use it, your code is vulnerable. With access control and business logic vulnerabilities, it is still the programmer's responsibility to make sure his or her code is not vulnerable.
So if I use a modern technology stack with advanced JavaScript front-end frameworks, ORM, and also use access control libraries, am I safe?
No, you are still not safe. There is no silver bullet to prevent all kinds of attacks. You cannot choose a certain technology or add a specific defensive mechanism to mitigate all applicative vulnerabilities. Secure coding is the outcome of a complete process of Secure Development Lifecycle, or SDLC.
What about web application firewalls? Can these stop applicative attacks?
Web application firewalls, or WAFs, are not designed to block business logic and access control related attacks. They do, however, partially help blocking SQL injection and cross-site scripting, but they can be bypassed. For example, in SCI, we found a cross-site scripting vulnerability in a website that was protected using a web application firewall, and by using a combination of 6 different evasion techniques, we were able to bypass the WAF. In this specific example, 2 parameters were vulnerable to cross-site scripting, and this enabled us to split the payload into multiple parameters. Note that we deliberately write the parameter that appears first in the HTML, second in the URL, and vice versa. This is in order to bypass word sequence inspection. For example, if the WAF is searching for the word document, then the word body, and then inner HTML. One cool way to run code in an XSS attack is to use an input text box, add an onFocus event with the desired code, and add the autofocus attribute. This runs the code without user intervention. Then we added JavaScript comments in order to comment out any HTML that interferes in the middle. This enables us to divide the payload between two parameters properly. A great way to perform an XSS attack is to rewrite the whole HTML document by assigning a new value to the document.body.innerHTML attribute. But as mentioned before, WAFs look for this combination, so the bypass technique is to assign each part to a variable and then access that variable. We assign document to variable A, then assigned a.body, which is document.body, to variable B, and then we edit b.innerHTML, which is actually document.body.innerHTML. When we have the ability to edit the HTML document, we can assign it with a new HTML as a form of a string. So we can use string concatenation in order to split suspicious looking words like on, error, and alert in order for the WAF to miss it. Finally, we use the image tag with a non-valid source and an on error event which contains the JavaScript code that is executed once the image fails to load. The final outcome is an alert pop-up, and this can be replaced with any malicious code that we desire.
So what do you recommend I do?
Follow the secure development lifecycle best practices, including the following. Use modern security tools, such as SAST and DAST, static and dynamic security testing tools, to scan your code and running applications. Update your operating system, libraries, and frameworks regularly to prevent exploitation of known vulnerabilities. Scan for outdated software using SCM or Software Composition Analysis tools. Perform secure development lifecycle or SDLC training for your developers to raise awareness and make sure they write secure code. And conduct periodic penetration tests and red teaming activities to make sure your application, infrastructure, and organization are safe.
If I follow these best practices and find multiple vulnerabilities, what should I do next? Where should I put my next dollar?
You need to correlate all found vulnerabilities to the business impacts, attack path, and costs in order to create a cost-effective mitigation plan. Creating a cost-effective mitigation plan requires in-depth information for you to decide what you should invest resources in. As an example, we here at SCI provide our clients with a data-driven attack path graph that can show how different types of attackers can impact your business. We also show which vulnerability should be fixed first in order to break the attack path.
Application security sounds like a minor topic, but in actuality, it's a big one.
Development is an ongoing and never-ending process, and so is application security and security in general. Security resources are limited, and you should have all the data and think hard before you wisely choose where to put your next dollar. Thank you everyone for joining our Cyber Talks. See you next time.